Hi everyone, today I'm here to talk about the ransomware attack. Ransomware attack have become a prevalent threat targeting individuals, businesses and organizations worldwide. In this presentation, we will explore the stages of ransomware attack and discuss strategies to protect ourselves against this evolving threat. There are many stages in which the ransomware attack has been compressed. They are the initial compromise, the execution of payload, file encryption, ransom note, ransom demand, communication, payment, and decryption.
This is the folder that we are going to encrypt. So let's check whether all the files and images in this folder are executable and accessible. All the files are accessible. When the system is attacked by a ransomware malware, a malicious code will be installed in our system. Let us assume that this is the code sent by the attacker. Now let's execute this file in our system and see what happens. Once the code is executed, we could see that all the files have been executed and encrypted. All the files and images in this folder have been encrypted. Usually a ransom note will be left by the attacker. Here payment.html is the ransom note.
In the real world scenarios, this ransom note will provide information on how to send payment, amount to be paid, and warning about permanent loss of access to file if payment not received. Once payment is received, the attackers will provide the decrypted file. Here solution.py is the decryption file. Let's see what happens when this is executed. We could see all the files are decrypted and becomes accessible.
This set of code is for the data generation. The synthetic data is created to simulate characteristics of files including size, sections, imports, exports, strings, entropy and whether they are malware or not. And the next set of code is for the data handling. The synthetic data is saved to a file called m.csv. The data is then loaded back into the data frames. The data set is prepared by the features and the target variables, whether it's malware or not, are separated. And the data is split into two parts, a training set and a test set. The test set will be used to check how well the model performs on new and unseen data. The model creation and training will be done by a random forest classifier. The random forest classifier is created and trained using the training data. The random forest model learns to associate the file characteristics with whether they are malware or not. The model is evaluated by the training model. The training model is used to predict whether the file in the test set are malware or not. The accuracy of the model's prediction is calculated and displayed as a percentage.